Testing. 1, 2. Test. Mic check. 1, 2, 1, 2. All right. The purpose of this recording is to discuss special protectors and issues influencing the effectiveness of hearing protection devices. Topics for discussion include special protectors, noise reduction, hearing protection device attenuation in the real world. Devices designed to improve the ability to communicate and hear warning signals in situations in which HPDs must be worn include level-dependent protectors, noise-canceling protectors, and communication headsets. Level-dependent HPDs, sometimes referred to as amplitude-sensitive or nonlinear HPDs, provide different amounts of attenuation depending on the sound level in the worker's environment. They are intended to allow low and moderate levels of sound to enter the ear while attenuating high-intensity sounds. They allow the wearer to hear low-level speech and warning sounds while protecting against noise at hazardous levels. These devices may be classified as either active or passive. Active HPDs use electronic circuitry to accomplish level dependence. These devices use an amplifier to permit the passage of low and moderate level sound. At high levels, such as 80 to 85 dB, the amplification stops and the device attenuates like standard hearing protectors. Passive level dependent HPDs are referred to as shooter's earplugs. These devices attenuate high-level sounds through small holes or valves while allowing a low-level sound to be heard normally. These devices provide little or no attenuation below 110 dB, so they're best to use to protect the wearer from impulse noise like gunfire. Noise-canceling HPDs, or active noise reduction devices, generate a signal in the HPD itself that cancels certain incoming sounds. Noise-canceling protectors are most effective at reducing continuous, low-frequency noise below 500 Hz. The extra low-frequency protection can help in environments dominated by low-frequency noise, such as locomotive cabs, aircraft, military vehicles, and in certain industrial settings. When communication is critical for job safety or performance, communication headsets may be an effective solution. For these devices, a receiver is built into the headset, providing radio communication and attenuation in the worker's environment. The microphone is often noise canceling, which allows better communication. Some headsets have limiting devices that prevent the radio signal from attaining hazardous noise levels. Ordinary earbuds that come with personal listening devices provide little useful attenuation and are not recommended for use in an HCP. Moreover, if a worker listens to music through a headset, they might be tempted to turn the volume high enough to override the background noise, which may lead to temporary or permanent hearing loss and reduce the ability to hear communication and warning sounds. There are earbuds that exist that allow a wearer to listen to music or other audio entertainment at safe levels. These devices are different than ordinary earbuds because they provide hearing protection and are labeled with a noise reduction rating. Many of these devices also have an output limit on the volume control to help prevent the listener from damaging their hearing. Fortunately, today, earplugs and earmuffs have a uniform or flat attenuation. This means that attenuation is evenly spread across the frequency spectrum. The advantage to uniform attenuation is that they reduce low frequency noise as effectively or nearly effectively as high frequency noise. Most HPDs provide the benefits of flat attenuation only when they are inserted and worn properly. Specially designed helmets that combine hearing protection with communication capabilities can meet the need for military, law enforcement, and other situations. Dual protection or double protection consists of wearing earplugs with ear muffs. Dual protection can be helpful in very high noise levels or levels above 105 A-weighted dB over a long period. Employers can require the use of dual protection, especially if a worker demonstrates progressive noise-induced hearing loss. Dual protection should be recommended only during high noise level exposure to prevent overprotection. The attenuation of HPDs is measured in the laboratory with a standardized procedure called real ear attenuation at threshold. It is a hearing measurement procedure where thresholds are measured using narrowband noise signals instead of pure tones, and the signals are delivered through loudspeakers. For each frequency band, the person conducting the audiometry compares the threshold measure when the HPD is worn to the threshold measured when the ears are open. The difference is the threshold shift caused by the HPDs. These tests are typically done with a panel of 10 to 20 subjects, and multiple measurements are made with each subject. From these test results, the group average attenuation and the variability of the data is calculated and reported on the HPD package. The noise reduction rating specified by the U.S. Environmental Protection Agency must be displayed on HPD packages sold in the United States. It is a single number rating calculated from real ear attenuation at threshold results across all frequencies. The NRR was intended to help consumers choose an HPD, but it does not accurately predict how much everyone will hear when wearing the HPD. Selecting the right amount of attenuation requires finding the right balance of protection and communication. The greatest risk for workers is wearing HPDs with too little noise reduction or that don't fit properly, resulting in overexposure to noise and permanent noise-induced hearing loss. Without measuring the attenuation obtained by each individual worker, known as the personal attenuation rating, it is difficult to know whether the worker is underprotected. Overprotection caused by too much attenuation may not only interfere with communication and the ability to hear warning signals, but it can cause a feeling of isolation that separates workers from the world around them. The Canadian Standards Association recommends that employers select HPDs that reduce workers' noise exposure to 70 to 85 dBA weighted. If an HPD reduces the worker's protected exposure below 70 dBA, the wearer is considered overprotected. Numerous workplace studies have indicated that workers wearing HPDs on the job often obtain less noise reduction than the NRR indicates. These studies report the actual field attenuation that workers received on average only about 1/3 to half of the attenuation that was measured in the laboratory. In addition to variability among workers, as shown by the standard deviation in the table on the previous slide, was 2 to 3 times higher in the workplace. There may be many reasons why people in the workplace do not receive as much noise reduction as subjects in the laboratory test. First, in the laboratory procedure used to calculate the NRR, subjects are usually highly trained listeners, and the experimenter selects and fits the HPDs on the test subjects. The protectors are sized carefully, and the earplugs are usually inserted very tightly. Many workers have had minimal training in the proper fitting of HPDs and do not insert the earplugs as deeply in the ear canal, possibly for comfort, the need to communicate, or simply because they don't know how to fit them correctly. In addition, earplugs may become loose during the work shift as the worker chews and talks. In addition, earmuffs may not provide as much noise reduction when safety glasses, goggles, or straps interfere with the seal of the cushions against the side of the head. It is also important to note that the NRR does not consider unique head configurations or situations in which the earmuffs may dislodge, and earmuff performance may deteriorate if its seals are not replaced as often as necessary. OSHA and several other hearing conservation organizations have endorsed fit testing as a best practice for estimating the attenuation obtained by individual workers. The fit testing systems are also known as field attenuation estimation systems. In summary, special protectors are devices designed to improve the ability to communicate and hear warning signals in situations in which HPDs must be worn. The noise reduction rating is a single number rating calculated from real ear attenuation at threshold across all frequencies. The NRR was intended to help consumers choose an HPD, but it does not accurately predict how much everyone will hear when wearing the HPD. Later.